As you might guess, it will be something about time. The title is about traveling in time with SQL Server, and I hope you like such journey. But as you know, in SQL Server, we have a lot of data that can have something to do with time. So thanks to our sponsors who allows the organizer to run the event, we have to be especially thankful for them. So we could meet today in Prague on Saturday. And now a few words about me. So I come from Poland. I work with SQL Server for over 15 years. I found that it's 18 years actually, so I'm a pretty old guy. For 10 years I've been SQL Server MVP, previously SQL Server, now it's data platform. And what I do, I just do consulting and everything what is related to data platform as of now. If you would like to see, there is a blog which is called sqlplayer.net. You can take a look into that blog. Me and my friend Kamil, we try to add some values, I mean some good articles or something like this. And today I invited my daughter Dominika. She will run all demos for you. So today, because it's Saturday, I'm not working on Saturday, so she do all the bad stuff and I just be explaining you what is there, at least if I can. So let's move forward because we do not have that much time. This will be about time, so I will be talking about traveling in time, but it will not be about actual cosmic journey. It will be about how our data travels in time, which is very important, or how data changes over time and how we can capture those changes. So, what we have right now, because we have a lot of options, so at the end you may ask yourself that this particular feature, you don't have to use it, because you have so many other options you can use right now. So why the new one is better than the previous one? That's the previous ones. That's the goal of the session, to show you that you can use pretty new feature. And the good thing about this feature is that this feature is available in all editions of SQL Server. When I did the talk for the first time, SQL Server has a feature like change data capture, which is pure enterprise feature. You have to pay a lot for enterprise edition. Right now, it's not the case. You can have all of them in standard edition and even in Express. So we have triggers, so let's move to the next slide. We have triggers. Triggers are the easiest part. You can implement it very easy. You can spend 10, 15 minutes, you have all done. They work on all actions we are interested in. I mean, insert, update, delete. Very easy to do. But if you think about just one little change in your database structure, you do just a DDL statement that changes the structure, then your trigger may fail during the next execution. This is the weak point of the trigger. And of course, we know that in trigger you may have problems with this at identity information, because you can call one trigger which triggers another one. So the identity information might not be the one you would like to have. And of course, which is a very good thing, the trigger is transactional. That's the last point before the transaction is committed to a table. So it gives you great flexibility because you can make a decision. I want this transaction to be confirmed in the data, committed in the database or not. Okay. The next thing we have is, for example, stored procedure. Yes, stored procedure, a trigger is a special kind of stored procedure. So whatever I have said about triggers is more or less also true for stored procedure. The same weak point, I mean, when you change a source table structure, the stored procedure may fail at some point of time. We don't want to have this. And of course, stored procedures are called from the application. So that's, in my project, stored procedures are used to exchange information between applications and database. This feature, like a change tracking, is a feature that has been added in 2008 and allows you to have the latest version of the data. You don't see how the data evolve over time, so you don't see every single change, but you only see the actual version of the data. Also, insert, update, and delete in change tracking. You have to change it. You have to turn it on a table level, of course. And single table can have only one change tracking related table. And the more complicated solution, the most complicated solution, but also the most flexible one, is change data capture, which I described you a little bit earlier. You can have up to 2 CDC tables for one regular table. So in case of table structure changes, you can quickly generate another CDC table, and you don't have the pain that something is broken and something is not working. That's eliminated in this solution. All changes are stored, so you see the complete history of your data. So you know how data changed from point in time point A up to point B. You have everything. Perfect solution if you would like to load information to your data warehouse, for example. So that's a really good solution for this. And having said that, we have information about temporal tables. So let's move to the next slide. And we have this new feature, which is called temporal tables. And by temporal table as a single form, I mean that there will be 2 tables. One, I call it base table. The base table will have only one version of row. So that's the version as it is right now, so the row from the actual point in time. And there will be a historical table. And this historical table will see all changes you have done through when you work with the database. How can you use it? There are a lot of possible scenarios, for example, where they can be very useful. One of them is slowly changing dimension, which I don't agree. And I explain you why in a moment. This is marketing slide. Sorry, I put it there because it's beautiful. In terms, we see a lot of scenarios. But I see that the slowly changing dimension it may not be what you really want. But what is true, you can really repair some problems with, if you lost data in one of or many rows, you can try to repair or you can try to get the data back because you have all historical changes. So we don't have to do all workarounds. We can just try to work with this solution. And I try to explain you how to prepare your table to be a temporal one. During the demo, we do 2 scenarios. One, when you start a table from scratch, so you basically have nothing, and your table become a temporal. And then, which is more common, you have a table with data, and you would like to change it to temporal. So that will be the scenario. So there are actually 3 slides. How should you prepare your table to be a temporal? First thing, which is obvious, your table has to have a primary key. I bet all your tables have primary keys. Then you have to mark the table to be system versioned. That means that from that point, SQL Server treats it as a temporal table. You have to add 2 non-nullable columns, which should be type datetime2. One column will be responsible for starting point in time, the second column for end time. So let's move forward. And next, there will be a point that I also don't agree, because you have selected 2 columns that describes that this is my starting point, this is my ending point. But despite this, you have to add one more statement, which is called period for system time, and you have to specify which column is starting point and which is ending point. Completely nonsense, but sorry, it works that way. You have to put this. Then you have to, then you can specify how the historical table is going to be created. It can be fully managed by SQL Server, and you will see that on the demo, or you can have a little control over how this table is created. And I tell you what can you specify in a moment. And in both cases, no matter how they are created, the tables are created, the table will be page compressed. And this was first significant sign that 2 years ago, that this solution will not be available in all editions of SQL Server because page compression was enterprise feature. And from some point of view, some moment in time, like in May 2016, suddenly this feature became available also in Express. So I asked them why, because page compression is not available in Express. And that was the first sign when Microsoft said, okay, it might not be very important in short time. And we know what happened in Service Pack 1 of SQL Server 2016. Okay, what should we do next? When you will do queries, remember that there will be two tables, the base table and historical table. You cannot change directly data in the historical table. It's possible, but you have to turn off the versioning. If you have temporal tables, you cannot change that, data in historical table. Of course, truncate table will not be working. DBCC check constraints work a little bit different, and you have some link here. DBCC check constraints also has some checks if your data ranges agree. So means that something is earlier, something is later when rows are analyzed. Okay, let's move forward then. And this is how we should start to work with temporal. Sorry, I want to make all those slides as fast as I can because we have a lot of good demos. You create a regular table, but you have to add some special phrase to make sure that your table is aware of being temporal one. All operations, I mean DML operations, and selecting data in the classical way, you see select from temporal table will work exactly the same. It's transparent. But if we do temporal querying, so that this is special phrase, so select from temporal as of, from to, between, or contained, then this feature starts to work. And you can create temporal table, but if you don't use this model, nothing has changed. So you don't have to do anything, and your temporal table will behave as the regular one. But if you change, if you would like to use the temporal things, then you see that from that moment of time, if you use that phrase, you will see also your historical data comes to light. How it works? Very quick example. You see we have two tables. This is temporal table, which is called department. The upper part is the actual data, so the base table, and we have some history. To make it simple, you see the from and to columns, those are just years. We know that it should be date time to column. Imagine that that's okay. We have two actual rows, row number A001 and A002, and you see the rows have some historical information. And there is also row number 3, which is not present in the actual data, which means that the row is who wants beer, because I have beer, he gets beer, deleted. So you won, please come later, and I have a lot of beer coupons, so be more active. I don't drink that much, so I have to give it to you. Okay, let's move forward. This table is actually seen like this, as a single table. So the light blue rows are the actual. And we have some queries. So if you call a query like this, what you see is you are going to see the actual version of rows. But if you do a query, let's move forward. If you do a query like this, so you you say, give me for system time as of date, means that you want to know what is the version of the row, so what is the state of the row at this particular time, moment of time. And this can give you only one row per primary key. Because a row can have only one state in a single moment of time. But there are a lot of queries we can do like this. So for example, if you say, give me versions of row between those two dates, you can have more than one row per primary key, because row can change many times in time range, and you will see that. And you will see that. So for example, for row number 1, A001, you can have two versions, the actual one and the historical one. And the last query I would like to show you is the query for contained. Contained means that the row has to be exactly contained between those two dates. So in that case, you will see only row A003 that was present. Okay, let's move forward. How it works? Imagine that we do some operation on like a loading data. When you do an insert to a table, that means that we do not have any historical information. It's just insert. It's the information that is right now, at the moment. So nothing has been transferred to the historical table. But when you do update or delete, and the row already existed, because when you do update means that the row is there, then the actual value of the row is stored in the base table, and the previous version is transferred automatically to the historical table. That's how it should work. Same for delete statement, okay? So now we'd like to read data. When you do a regular query, like a select from table, then you have only information from the temporal table without touching the history table. But when you do a historical query, so give me as of time or contained in, then your query automatically checks if there is something in the historical table as well and sends you the proper result back. And that's not all. That's only half of the story. But it's almost last slide. And the last slide will be now. What if, because what I can imagine is that the base table is the small one, only one version per row. The historical one will be growing and growing and growing over time. At some point, it will be so huge that you might not have that many space in your database on your disk drive. And what can you do? You can do a stretch. I mean, you can somehow divide this table and put it to the Azure SQL database. So what you can do, you can effectively write a function. Imagine that. You can write a function, and this function says, if data is older than half year, move the data to Azure. So you will have a solution like this. One version of row in base table, data not older than half a year here, whatever is older is automatically transferred to Azure. And when you do a query in that case, you will have proper result in all cases, because SQL Server knows what is transferred to the Azure part, what sits there, and what is the actual row of the actual version of the data. Okay, that's all in terms of slides, and now we do some demos. So we can close that. And let's check, yes, we still have the connection. Let's make it bigger. Can you read that? Can you read the text? I can, okay. So let's create the database first. And let's check what can we do. This will be just regular database. You see everything is fine. And now we do some scenarios. First, this will be a table which is called product. And you see how it is constructed. It has 1, 2, 3, 4 columns. Those are business columns. And then you have sys start, you can call the column as you want. I call it sysstart to show you that this is the temporal, this is the technical column needed by this feature. And it says I am generated always when I insert the row, and sysend means that I am generated always when the row is will be sent from this table, and that period for system time, which is not necessary, but you have to put it there. It's required attribute. And then you have information system versioning on means that the table will be under control of the SQL Server, and this will be actually a temporal table. Let's run it, and done. Okay, that was first scenario. We start from 0. Second scenario is exactly the same, but there is a little change. You see, I named the table as I want. So I say history table, and I put name of the history table. So in first example, SQL Server will name the table for you. And you can imagine it will not be a pleasant name. I will show you the name in a moment. In that case, I have control over how the table will be named. What can I do else? I can specify if the compression is set or no. I can say that I would like to have partitioning or not. Remember, historical table tends to be big. So you can have your own partitioning strategy. It is not transferred from the base table to the historical table. You have to do it manually. Okay, let's run this. And I have 2 more examples. Go to the editor, and I have 2 more examples. Table 3 and 4, right now, they are just equal. So you can run table 3 and 4. Those are just business tables without historical information. And I will use those tables to show you migration scenarios. Okay, run also for table number 4, so query number 5. And let's see what has just happened. Let's check how our database look like. So we should see temporal demo, that's our database. Let's go to tables. And right now, you see we have 2 temporal tables. You can see them because they are blue. And in first example, so let's check how this table looks like. You see the table name, it's MS SQL temporal history for something, and object name. And this object, this is object ID 9015, etc. In the second case, I have the other object named properly as I want, so it's easy to read. And as you may imagine, we will be playing with product V2 version. And my question for you, and it can be even worth 3 beers, not 1. How indexes look like now in the historical table? Do you think that SQL Server created some indexes for us? Think about how the historical table is constructed. What can we see there? Do you have a yes? Question? Yes.
There must be no cluster index because there will be duplicates with the same ID.
We can have duplicates because it's historical table.
Yes, but in historical data,
yeah,
we cannot copy the cluster index.
We cannot. Great. 3 beers for you. So let's check how the index look like. And this is the index definition. So in the base table, the index looks as you want. The index definition is not copied to the historical part. This is clustered index that has been created automatically, but feel free to change it. It's up to you. You know the business, you know the strategy. You can have different index because of your partitioning, but that's the best definition Microsoft can guess. The clustered index is on end column and start column because those are the most typical queries. This is how you are going to query the table. Okay, let's close the index window. No, we don't want to save that. And let's move to our queries later. So you know what just happened. And now let's run that part. So I'm going to insert data to this product V2 table, and I am go to result, And I am asking what is in the base table and checking also the historical table. Normally, you don't need to call the historical table anytime. It's just for the demo purpose to show you what sits there. And as you see, when I insert data, nothing is there. That's right. What I want you to see right now, take a look how the sysstart looks like. It's date of the beginning, so it's insert date. And sysend is something which is really in the future. This date is really in the future. We will not be alive when the date comes. We will be dead. SQL Server will be dead, and Microsoft will be dead too. So this is infinity. This is how infinity looks in SQL Server. So don't worry, you can write your solution till that time will be dead already. But I'm optimistic all the time, so maybe. Why it's not, this solution will not be perfect for the slowly changing dimension? Because the dates are controlled by SQL Server. You cannot push the sysstart date and sysend date. No way to do that right now in this implementation. And this is why one of the reason it's not perfect solution. It could be in the future, but not now. Okay, let's move to another example. Now I have question, could be 2 beers if you wish. Now I'm inserting 5 rows. I like when it's silent like this. Beers always win. I'm inserting 5 rows, and tell me what will be the start date. The same for all rows, or each row will have different? The same. You have chance to win the beer. Let's run it. And what we see, let's go to result tab. Yes, you're right. So from row number 2 to row number 6, you see sysstart is exactly the same. That was a simple example. It was only worth 2 beers. But I have a little bit more complicated. Let's go to the editor right now. And let's check the transaction. So query number 8, we have a little bit more complicated part. Let's run it, and I will explain what's going on, because it takes actually 10 seconds. So let's run the query. I'm starting a transaction and noting time. Then I'm waiting. Then I'm inserting data and waiting again. And inserting and waiting again. And committing transaction. Those are dates. You see, this is, the server is actually 2 hours behind us. It's somewhere in West Europe. So you see, this is, we have every date is moved in history in 2 seconds. I inserted 2 rows. The first insertion was in wait number 1. The second insertion was here. What will be the dates, the start time of each row? From the start transaction, from end transaction, each of them will have independent start time. 4 beers. Commit, start, and you won. And this is something which is really dangerous, because you can have, let's show the results. So this is the, yes, go to the editor. And we'll see the results. Scroll down and run the X query. And you see that the 2 rows will have the same, so row number 7 and 8, they have the same date, and this is starting transaction time. This is because SQL Server works that way. SQL Server knows when it starts the transaction. That's marked in transaction log. Imagine a situation that you have long-running transaction and you put many rows to your database. All of them will have the same starting time in that case. You can answer the question if this is something you want or not. If you don't like this, you have to split the transaction into a smaller part, and that's enough. That's enough what you have to do. Okay, let's move forward, because it's not enough. Now, what we do? Now I would like to transfer data from V2 table to the products table, which has been created by SQL Server. I can do it that way. The question is, what do you see in the sysstart and sysend time? Run the query, and we see if the times, and go to the results, and we see if the times, they has not been transferred. The sysstart and sysend during loading data are generated one more time. So when you have tables which are already system versioned, if you would like to transfer times from another table, you have to turn the versioning off and turn it again. Okay, let's move to the next point. And what if you would like to do something like this? I would like to take this sysstart and sysend columns because I know that there is a valuable information. So if you try to run the query at this moment, error occurs that you cannot affect auto-generated columns in any way. So you have to turn off the versioning first. Okay, next demo, what we have there. I would like to now tell you about how scenario of changing table which was not temporal and will be temporal in a moment. So I load data from V2 table to V3 and V4 because I have two different demos for it. So let's run the query right now. So I'm going to load data. Those will be just, you see, regular data like this. This is a table like you may have in your application right now, and we now change the table to the temporal table. So let's run the next query. What you have to do, remember that changing a regular table to temporal one must always be done in single transaction because you are adding two columns, sysstart and sysend. You have to make them not nullable. So I put some constraints, but I'm removing the constraints later, and I'm creating historical table with no name. So this is the entire step. Please run the query. And you see this is the entire, this must be done in one step. You should not divide it into single smaller steps because, as you know, it may fail or not. So that was one part, and let's see what happened and what sits in the table right now. So let's call query number 13. So we see what is in historical table, what is in products table. And you see that everything was transferred to the, run the query. Everything was transferred to the main table. Dates are exactly as we decided them to be. So they are from the beginning of age, and they are ending in infinity. Okay, as you see, let's go to the editor, and you see that I just called select star. Anytime you call select star, all your columns will be displayed, yes? So also those two technical columns. But I don't like those technical columns. Can I do something that they will not be displayed when I do select star? Yes, you can. In the second example here, you can see that the sysstart column is generated always as row start, but its attribute hidden. And this is what solves your problem. So let's run this query 14, and then we call select from products. Okay, let's go to the editor, and let's run select star. And right now you see that those technical columns are not visible. You have to explicitly call them. And this is what you see in the next query. So if you really need those columns, you have to specify them. And you see IntelliSense doesn't like them. They mark them as red, but everything will be fine. So you can run the column, you can run the query. So you see that those columns are really available and you can use them if you want. But if you don't, then no worries, there is a way not to display them. It's important because if you don't want to break your application by adding two more columns in SQL Server, then you should definitely attribute them as hidden. Okay, what do we have next? Well, we would like to change the structure of our table. So in the demo number 17, take a look. I want to add another column. So I have 7 columns and I want to add another one. Is it enough just to issue alter table with new column definition? Should I care about historical table? No, everything will be done by SQL Server. So please run the query and you see that the column which is called color has been added automatically by SQL Server to both tables. This is historical table. So you have them in, you have it automatically in all tables.
What about deleting? What if we delete the column?
Same situation.
It will stay in history?
Yes, yes. Let's move forward. And the next steps that are here, I'm showing you different situations you may face. And please run the query on your own and you see that because we move forward, we move forward to the query number 27 as I can imagine. What was earlier, sorry, 20, move up. It will be 23. I did 4 examples for you. When you have control, when do you put the column? So you can turn the versioning off and you can put the column to the base table, but you have to immediately put it to the historical table as well on your own. And then you change the table to temporal. And the definition of those columns must be identical. For example, in one of the examples, there is a definition that color column is varchar 20 in base table and varchar 50 in historical table. And SQL Server says, no, they are different. Those are different columns. The definition must be exactly the same. And now, this is the moment when we start playing with temporal tables. So, run the query 23. This is what we have. We are going to update rows number 5 and 6 because they have price 4 and 5, so I'm going to change the price right now. When I update, I should be able to see something in the historical table. This is how the mechanism works. So let's run the next query. Okay, take this window, that's fine. So let's make 23A. So I'm updating, and let's go back to the editor and run those two. No, it's enough. Only the select statement. No. Only the select statement, those two. Okay, let's run it. And you see what we have here. The the price of product ID 5 and 6, the price was 4 and 5, and as of now, the price is 40, if you see the row. So now you see the history. Now you see how SQL Server reacted on your change. So every row change once, and you see the effective date from start to end. And if you even try to see the end time is 14.9, and the same is as the sys start in the base table. So my question worth of 3 beers would be, what exactly happened in this time? If you ask about this time, which version of row do you get? The historical or the base? I said 3 or 4 beers. Could be 4. Do we get historical or base? Base. I don't have too much beer. All of said you said base, so we'll see. Okay, let's move to the new query. And now we do something really nasty. Query 24A. Okay, let's see this one, because I'd like to point you to the row where it is. The last row, the price is 11. And you see something, we do right now something very nasty. So go to the editor and take a look at this query. What we are going to do. We are changing price of the row from 11 to 11. One time, second time, one time, second time, 2 times. Is it a change or not? Yes? You want a beer. So let's run the query, the entire query, and you see that from SQL Server point of view, you are changing the row. That doesn't matter that you enter the same value. You issue DML statement. DML statement is saying you are changing the row. It was update. You updated with the same value. It's up to you. You should know what you do. So you see that the row, now you have the third version of the row. 2 of them are historical and they sit in the historical table. Okay, that was not the most nasty thing you can do. And let's move to the next example. This is the most nasty thing you can do, in my opinion. I'm single transaction, so you know what is going to happen in a moment. I'm inserting the row. I am updating in one time. I'm changing the name because we have to find the rows in a historical table in a moment. So I'm changing the name of the row from ZZZ to number 1. I'm doing the second change to number 2, and I'm deleting the row. Where is going to be the row after the transaction? Let's run it. Do we have something in the base table regarding to those rows? No. You want a beer. Let's run the next query and we see what is exactly, oh, it's a little bit up, and number 26. And you see, this is the row. It has number 9. It started from ZZ, then I changed it to ZZ1 and changed it again to ZZ2. What is the problem with the row? If I didn't change its name, you wouldn't be able to find which was the first one. Because they were in the same transaction, I would have to jump to show you this. Those 3 rows were created, updated, and deleted within the same transaction. Start time and end time is exactly the same. So if I didn't change its name, you wouldn't be able to differentiate which was first, which was second, and which change was third. So that was also a use case. You have to remember about this. So now we would like to show you how the query looks like. So let's check what is in the products table, and we pick a product, one of the products. Okay, so let's pick product number 5, and we need what we need. We need the start date of product number 5. Okay, can be that one. And let's go to the editor, and let's check how the temporal query look like. So what we have to do right now, let's change the query. So I'm just putting the value, but this is the moment when the row was inserted. And as you remember, row number 5 was changed. That was the first change we have done. So how the query look like if I ask for the moment before the change. So run this part of the query. So we should be able to see that we have rows, and you see the price of product number 5 and 6 is again 4 and 5. So I just run a regular query with different, let's go to the editor, and you see I use the special statement for system time as off. And in that case, SQL Server knows that you are also interested in history. If you ask about this moment of time, it analyzes what was the row state and gives you the information back. Turn off planning, so we see how the plan looks like. You have to turn on the plans. Okay, that was it. And you have to paste date, valid date here before you run the query. So I would like to show you, okay, and let's run this. You don't have to change. The number 9 is okay, because I would like to show you something like this. When we run the query, we have 2 tables. you don't see when you issue the query, you don't see that two tables are involved. You think only about one. The upper table, so clustered in the seek, the upper one, is for the base table. However, the clustered in the seek here is a seek in the historical table, which was done by optimizer. You don't have to query the historical table on your own. You just ask about data, and that's all. SQL Server does everything for you. You don't have to write your own solution. Okay, let's move down, because I have two more things for you. Let's move down. Those are all, in the green part, those are all things you can run for different types of queries, and you see what are the conditions, how the query will be evaluated. All of them you can see. So if you, for example, say as of date time, then you have information that this is specific point of time. If you have contained start time, you see how the columns conditions are displayed. So play with that, but we move forward because I would like to show you stretching. And stretching takes 2.5 minutes down. This is, stop here in 34. What is done between query 27 and 34 is when you change historical table. I ask myself, I know it's stupid, but I ask myself, what if I change the historical table for my table that already has one? Your base table can have only one historical table. And I would like to change it to another table. So that code shows you how to do this, and at the end you have to say, okay, it was a stupid idea. Because you lose all your history, you can switch the table back, but at some point you may lose something. What I would like to do, I would like to show you how stretching works. Stretching was the last slide. When you have that big table that you would like to offload it to Azure. So let's do it. So let's run query number 3. First of all, I have created Azure SQL database, and I updated its firewall rule, because otherwise I would not be able to contact. Okay, then I have to create, let's move forward. I created a master key because I have to then create a database scope credential. And this is the SQL Server. This is my identity, and that's my password. Don't worry, I change it right after the session. Don't memorize it. So run the query. So now we have a credential, and what we have to do, now we have to say that we would like to connect our database, which is called Temporal demo, to the, let's run it because it takes up more than 2 minutes. And let's move to the editor, and let's wait here for a while. Our database is going to be right now stretched. Some part of the database will sit on premise, whatever on premise is now, because all those servers are in cloud. So on premise means in this server. And some part of the table will be somewhere in Azure, but on what condition? And this, now I'm going to tell you about the condition. Let's go down. Do not run anything right now till I down. We have to say down, because I would like to explain those options. We have to write a function. And this is a function which will decide what stays on premise and what goes to Azure. And this function will be triggered automatically by SQL Server. So SQL Server is going to decide what to do with data. As you see, I'm going to move to cloud everything which is newer than 1st January last year. So effectively, everything will be moved to cloud after some time. You don't have to configure anything apart from that. SQL Server knows that there are new data and I have to check the function and move something to Azure. So move forward a little bit. And what we have to do, we have to run the query, but don't run it now. So we have to say that we have a table which is called product2 history. And this table is going to have this filter predicate function. And this filter predicate function is created one query, or will be created one query earlier. This function is going to analyze sysstart column, and whatever is newer than 1st January 2016 will go to the cloud. What does it mean will go to the cloud? How I know that it goes to the cloud? Because migration state is outbound. Outbound means that we are sending data. If you would like to, at some point, load data from cloud to your table, again, because you don't want to pay Microsoft for the SQL Server, you have to change this migration status to inbound. And it magically will download the data. This mechanism is not very fast. You will see how it works. It works in packages. It tries to take 10,000 of rows and move it to the cloud. So if you have hundreds of billions of rows table, it will not take seconds. It will be rather days. Yes? But remember that whatever you send there, the cloud is free. You have to pay when you have the result back. So it should be one-way ticket. Something like this. Okay, query is success. Let's move up because we have to configure it. Okay, let's down. Okay, down. Let's okay, 103 will be okay, or 100. Okay, let's run the first query, 101. Because we have to create this function first. No big deal, function is a function. Then we have to say that our table is going to send data to the cloud. Run the query. Fine, it was pretty quick. And then we have to check, let's run query number 103, because we would like to check which table is right now configured, and go to the results, because we'd like to see what table is right now configured to send data to the cloud. And product to history. Let's run next query. And the next query is going to tell us something about the configuration. So we see what's there. On the SQL Server in the Azure side, you will see that this is the name of the database that was created on the SQL Server in cloud for me right now during this demo. So that was what has been created. And let's move forward because we have only 5 minutes and I would like to show something to you. Let's move down. And there is query 105 or 106, sorry, 106. And this dynamic view tells you about the migration status. So what already has been transferred? If we are in luck, this mechanism just started to work, so please run the query. And we see we have like 11 rows in this table. Right now, no rows has been transferred. So SQL Server does not know that it should transfer something. Let's wait, let's be patient. It will do this for us. If not, I'm going to force it to do it. Okay, let's move next. There is a change in query 107. There is a change in a function which is called sp space used. We know it from years. Right now it has new attribute or new parameter which is called mode. So please run the query. And you see, we know the function as it is in the first query, so without this parameter. But right now there is a special parameter. It's still running, okay? So we have to wait a little bit. But we can still running. Okay, let's check the results right now. And as you see, the first is, I have 7 rows in total. The second query says that you have right now 0 rows on the premise side, and all 7 rows has already been transferred to the cloud. During I was talking, I'm trying to amuse you because we don't want to wait that much. But these 7 rows are already there. So let's check if there is true. So let's move to the query 106 once again, and let's run this query one more time. And probably now you see that the 7 rows has been transferred somehow for us. I haven't configured anything today. She did that. But it was no special configuration. We just wanted to say that, yes, please do this for us. And now we show you a demo. It will be the last one. So we are going to, so query number 108, run it in new window. So you see, this is, let's say, typical scenario. I'm going to send a lot of data to my temporal table. So let's run this query and go back to the first window. And what you see is right now this temporal table is flooded by rows. I'm constantly trying to update some row number 5 with some random price. So this will be done forever and forever and forever. And if we wait for a while, you see that those rows will be transferred to the cloud without our knowledge, just because it works that way. So please stop the query in the second window. And let's see, well, some rows has been inserted. And let's run query number 109. This 109 is not a query about migration status. You will see what has been created, that we have this remote table. There is an external source, like in, because you have to have external source to Azure. And this is what is my server configuration. But if you run the next query, this will be almost the last one. Then you will be able to see what already has been transferred to the cloud from the queries we run. So you see, previously we have only 7 rows. Then we run queries, and the data has been already transferred to Azure. I don't have control over that anymore. It just happens. So are you curious how our query plan looks like now? Because now SQL Server has taken into consideration the remote part of the query. So let's run almost the last demo. Yes, please. This is it. You can select it and run and show us the plan. It should be in a moment, yes. And you see the last part is remote query. And the remote query is the query to the Azure part. So SQL Server is now aware that there is something in Azure, that the table is effectively in 2 places. And he knows how to do this. The concatenation operator is nothing more than just union all. Believe me or not. But this is union all. So we have base data in the first clustered index seek. We have historical data in the clustered index seek in the middle. And we have remote query somewhere down. And we don't know how the query looks like. It's just remote query. And my very last question, because I promise that's the last demo. I don't have time. But let's go to the editor one more time. And I ask you a question. Let's go down. Let's go down. And what happened if I do something like this? So I'm effectively dropping the database. What is going to happen on the Azure side? The historical part will stay in Azure or will be dropped? Will be dropped. Stay. You will be like alcoholic man today. Why it stays? Because we don't want to lose data. Some part of the historical data still will be in Azure, and you have to remove them manually. It's good because we have data. It's bad because you pay for it. So remember, when you drop the table, you have to go and manually remove the database from Azure. Otherwise, you will be charged. And you know why is that? Because charging is fine. You have to pay for it. Okay, that's enough for today. Thank you for participation. Have a great Saturday. And welcome. I hope I will be there next year also. Thank you very much.